So part 2 of today's video series is actually solving for x with rational exponents and radicals. So let's take a look at these two questions. It says solve with rational exponents. So here, instead of simplifying the rational expressions, we're actually going to be solving where there's involving an equal sign. Now remember, when you're trying to get rid of powers, because that's really the goal here, is to get rid of those powers that you see, those rational powers. If we backtrack to solving something like this, x squared equals 4. How we got rid of the square was we took the square root of both sides. And that's actually the same as raising it to the 1/2 power of both sides, if you think about it in terms of a power, right? Square root is the same as 1/2 power. If we write it this way, notice here, basically what you're doing is you're raising it to the reciprocal of whatever the power is. So if you look at number 1, to get rid of that 3/2 power, what I'm going to want to do is raise both sides to the 2/3 power. And whatever I do to one side, I have to raise it to the other. Why do I do that? Well, what happens if I multiply these two, because it's outside the parentheses? When you multiply those two together, that just becomes x to the first, or just x itself. And that's what our goal is, to solve for just x. But notice the right-hand side, I still have to deal with evaluating 8 to the 2/3 power, which we kind of just covered in our last video lesson. So I can convert that to radical form, becoming the cube root of 8 squared. Well, the cube root of 8 is 2. So it looks like my answer would be 2 squared, which is 4. So there's my answer to number 1. In number 2, if I wanted to get rid of that power of 2/3, then I would want to raise the reciprocal to both sides. Again, the reason why I want to raise the reciprocal is if you multiply a number by its reciprocal, it always becomes 1. So here I get x minus 1 on the left side, or x minus 1 to the first, but then on the right side you still have that 25 to the 3/2 power. So on the right side you're going to want to evaluate that, converting it back to a radical form. So that becomes the square root of 25 cubed, and the square root of 25 is 5. And when I do 5 cubed, I get 125. And so my final answer, if I add 1 over to both sides, gives me 126 as my final answer. So let's take a look at a couple more. So what you're going to see on your worksheet is there might be some that kind of look like this, where you have sort of the same base, but now you have exponents that are variables. Again, we're still solving, so we're trying to see what x equals in those scenarios. But all these ones are unique. These are called one-to-one relationships. The reason why it's called one-to-one relationship is because you have the same base equal to the same base on the other side. And anytime that is true, if I have a to the x equals a to the y, then what you can do is, well, that means that the exponents must be true. And so you can just simply set the exponents equal to each other and then solve for x. So in this first one, 5 to the x equals 5 to the 10, well, that would be the same. Since the bases are the same, then I would just set the exponents equal to each other. So right away, there's my answer. So same thing here. If you see 11 to the 200, 11 to the x, then that means x is going to equal 200. Notice here we have 4 to the x minus 1, 4 to the 13th. Well, then that means since they're the same base, I can write the exponents equal to each other, and then we're solving. So if I add 1 over, looks like I get 14 there. So the one-to-one relationships are pretty direct. You just set those exponents equal to each other and try to solve. But then you're going to get some that look like this on your worksheet, where they're not the same base. But again, we still have to solve for the exponent. So with these ones, the goal of these ones is to try to get them to be one-to-one. Try to get them to be the same base somehow. Notice we have 3. 3 is sort of the most reduced base that you can ever write that number 3 as, 3 to the first power. But 9 I can actually write as a base 3. In fact, 9 is the same as 3 squared. Don't forget, you still have the x plus 4 all raised in the outside, but all I've done is just change 9 so that it's a base 3, 3 squared. We still have it equal to 3 to the x plus 1 on the left side. So now the next step is on the right side, notice we have an exponent that's outside the parentheses. And anytime we have an exponent that's outside the parentheses, to simplify that and get rid of the parentheses, we multiply those two things together. So here we actually have to distribute the 2 to both terms. So on the left side, we get 3 to the x plus 1. On the right side, if I distribute that 2 through, because you're multiplying the exponents, that becomes 2x plus 8. Now that they're the same base, now I'm safe to set the exponents equal to each other and solve for x. Here it looks like if I subtract x over and subtract the 8 to the other side, it looks like my final answer would be x equals -7. So just like with that last problem, notice here we have a base 2. So it's really, let's try to get that bigger base to write as a base 2. And 8 in terms of base 2, well, 2 to what power is 8? Well, it's 2 to the third would be 8. Don't forget you still have that x on the outside. And don't forget we still have 2 to the x squared minus 4. Now that I have parentheses, I need to get rid of them by, in this case, multiplying those two exponents. So on the right-hand side, I get 2 to the 3x, but on the left-hand side, I'm still left with the x squared minus 4 as a power. But finally, now that they're the same base, I can set the exponents equal to each other and solve for x. Notice here we have a quadratic equation. So to solve for x, I would want to get everything equal to 0, so subtracting that 3x over. And then I think that's factorable. In fact, that factors into x minus 4, x plus 1. So then my two solutions would be positive 4 and negative 1. So now I want you to see if you can try some of these. So in the first two, number 1 and 2, it looks like number 1 might be that 1-to-1 relationship, so you're ready to go. But notice number 2, we might need to rewrite those in terms of the same base. I'm thinking base 2 might be your the best bet there for number 2. And number 3 and 4, you're just trying to get rid of those powers. So remember, take the reciprocal of both sides and try to solve for x. So I'm going to give you some time to work these out on your own, so you can pause the video, try these out, and we'll check our answers here in a little bit. Good luck. So in the first one, notice we do have that 1-to-1 relationship, so right away we can just jump down and set the exponents equal to each other. And if I solve for x here, subtract x to both sides, I get -1 equals 2x plus 5. If I subtract 5 over, I get 2x equals -6, and if I divide by 2, looks like you should have got -3 for your answer. In number 2, we can't do that yet because they're the different bases, but I can write 8 as 2 to the third. Keep in mind you still have the x minus 1 on the outside. And I can write 16 as 2 to the fourth. We still have that 3x on the outside, so let's use parentheses. And since there's parentheses, then we'd multiply those two together. So 2 to the third raised to the x minus 1, I have to distribute that 3 to both terms here. So the left-hand side would be 2 to the 3x minus 3. On the right-hand side would be 2 to the 12x if I multiply those two together. Now that they're the same base, I can now set the exponents equal to each other and solve. So if I subtract 3x to both sides, it looks like I got -3 equals 9x. And if I divide by 9, -1/3 would have been your answer there. The last two you're solving with exponents, so that means you need to, so let's get rid of those exponents by raising it to the reciprocal power. So 3 over 4, if I raise it to the 4/3 power to both sides, that's going to make that a power of 1 on the left side. So on the left side I get x, but on the right side I'm left with 27 to the 4/3 power. So to evaluate this by hand, let's convert that right side into radical form. So 4/3 power is the same as cube root of 27 to the fourth. And if I take the cube root of 27, that's the same as 3, and 3 to the fourth power ends up being 81. So 81 should have been your answer there. In the next one, to get rid of that, I would raise it to the 5/2 power to both sides. So on the left-hand side, you're left with x plus 1. On the right-hand side, we still have 4 to the 5/2 power. Let's convert that 4 to the 5/2 power in radical form. So If it's to the half power, that means it's a square root of 4 raised to the 5th. And the square root of 4 is 2. And 2 to the 5th ends up being 32. So if I subtract 1, I get 31 as my final answer. So now you can finish the worksheet. I think the problem's 19, or was it 10 through 18 you should be able to do now. But the worksheet's going to be due next week on Wednesday when we take that mid-chapter exam. Have a great rest of your day and have a great break.